Hi, everybody. Today we're going to go through an example that deals with section 10.1e still on the test for the t-test for two means from two independent samples. This one, though, deals with some data. Okay, we don't have any summary information, we have data. So let's take a look at this example. This is an example that you have in your news items. Let me share that. Okay, so we have an engineer makes a claim that a new experimental procedure to cure an adhesive creates a stronger bond than an old method. Using the data below, the significance level is 0.05. Does this new method create a stronger bond than the old method? Assume the population variances are not equal. So since the population variances are not equal and we don't know what they are, we can basically assume we're going to do a t-test. And in fact, since there are two independent samples, the before and after, or the new method and the old method, if you will, we basically are going to do a t-test that's going to be a two-sample t-test, and we are not going to pool the variances. Why? Because the population variances are not equal. We're going to assume that. So the first thing we're going to do is we're going to clear out list 1 and 2, and we're going to input new data into list 1 and 2. We're going to put the new method into list 1 and the old method into list 2. So let me scroll down here for a minute. Let me show you what that should look like when you're all done. It should look like this first picture here, this first slide here, okay, where list 1 has the new method data and list 2 has the old method data. And we can see that the lists do not have to be the same size for the t-test. So now let's look at our formulation for H0 and HA. H0 says that mu1 is less than or equal to mu2, and HA says mu1 is greater than mu2. Now the question is, how do I get 1 and 2? I don't have it like the example we had the other day where in the table it said list or mu1 was this from this group, mu2 was from that other group. So in this case, I go back and I look at the claim. The claim says, going back up, the claim says that the engineer makes the claim that the new experimental procedure to cure an adhesive creates a stronger bond than the old method. So that means that since the new method is mentioned first, I'm going to make that population 1. Then the old method is mentioned second, I'm going to make that population 2 in the claim. That's typically the rule of thumb we use. So in this case, this is saying new method, the strength of bond for the new method is less than or equal to the strength of bond of the old method. That means it's not effective. It's no more effective than the old method. Don't change. HA says the new method has a stronger bond than the old method. So that means it is effective. And this is the claim. Our level of significance is 0.05. From the calculator, we'll talk about how to input on the menu with respect to the test itself and the output. We get 1.32, and we get a p-value of 0.011, or 0.1142. Note 3 and 4 are generated with the calculator. See input and output below. Let's look, before we look at that, let's look at number 5 and 6, step 5 and 6. The p-value is greater than 0.05, which means anytime the p-value is greater than the level of significance, we fail to reject H0. Since HA was the claim, and we failed to reject H0, we cannot support the claim that the strength of the bond is stronger with the new method. Okay? So it really is not overly effective. So now, this doesn't show up as well as I wanted it to. However, we can see it well enough. We make sure data is highlighted. We make sure these two reflect the lists we use. So we used in the new method L1, old method L2. Frequencies for both of these are always going to be 1. Regardless of the problem, you have 1 when we do this t-test, the way we're doing it here. Input in this line relates to what's in the alternative hypothesis. As always, the alternative hypothesis has a greater than, so we highlight greater than. We select no for pooled. Why? Because we're assuming the variances are not equal. And we enter. When we enter, we get 1.3166 for T, and so on and so forth. Again, we round to 2 decimal places, we get 1.32. Our next value is the p-value, 0.1142. Rounding, we get 0.1142 to 4 decimal places. And that's it. Hopefully this helps. Have a good day.